Hello, everyone. This is Jeremy Maestas here with the NRCS, and in this quick presentation, I'll be introducing you to low-tech meadow restoration concepts and techniques. And if you want to learn more, stay tuned for the end. We've got a link to some uh, modules that go through everything from reading the landscape to more on the techniques themselves and implementation and monitoring. So we all know that in the West, water is life. Life not only in the form of our biodiversity, but also our rural communities that depend on reliable sources of water to fuel working lands. But we're confronted with this widespread channel incision problem. And I know you've all seen this driving across the landscape, these valley bottoms where channels start to form and actually erode through the soil. And as that water table drops, our green groceries go away and we see a drying of our wet meadow and mesic vegetation. Those green strips on the landscape turn into upland vegetation and sagebrush. So if we can take degraded situations or incised meadows like the one on the left and put that soil sponge back to work, holding the limited moisture that we get each year, we really can take advantage of that natural storage capacity of the land that boosts soil moisture, productivity, and ultimately increases our resilience to drought, fire, and flooding. But we're confronted with this issue of scale. This is a figure from our friends at Utah State University, Joe Wheaton and company, a typical watershed scene where you could see most of those red lines in a watershed are those smaller order streams, upper headwater systems that may be just a meadow or ephemeral or intermittent systems that rarely get our conservation attention. But we need to be able to address these types of systems with techniques that are a little more cost effective if we're going to ever address the problem at scale. So introducing you here to the concept of low-tech process-based restoration. And many of you have probably heard about this type of work or been involved with it through Joe Wheaton's lab and the Beaver Dam analogs and low-tech process-based restoration workshops that he's hosted. And we'll talk broadly here about a suite of techniques that apply in perennial systems and our meadows. But what we're referring to are techniques that are simple, cost-effective, and efficiently scaled up. Structures, if we need them, are handcrafted using those natural materials locally sourced if we can use them. Ultimately, we want to help the system do the work. We don't want to have to babysit the system forever. And so we want to address the key processes that make systems functional again so that it can heal itself. And then also a key element here is engaging more people in the restoration practice, not just a highly specialized skill set, but enlisting the full breadth of people that are excited and want to contribute. So what processes are we talking about here? There's a couple of different concepts floating around that are basically saying the same thing. We've known for a long time that hydrology and geology, those physical elements of the system, shape stream and meadows. And we've often focused on addressing those components in our restoration planning. But in the last decade or so, there's really been a growing recognition of the importance of biology and ecology, not just as outcomes of stream and meadow systems, but key integral pieces in determining what these systems look like. And one of those key concepts relates to our meadow restoration conversation this morning, this idea of a stage zero. In our channel evolution model that's been around for decades, we've seen advancement in our thinking, a recognition that perhaps there were systems before a channel ever formed. These stage zero systems where water just flowed across, sheet flowed across a floodplain or a meadow. and maybe there were multiple channels or none at all, but the valley bottom was fully connected. And those systems were areas that we often ignored or walked past, and now we're fully embracing the idea that they were probably one of those missing reference conditions in many of our systems. And so we've got this whole suite of tools in the toolbox. I call them sticks and stones approaches, these structures, if you want to call them that, that are simple but designed to kickstart and facilitate certain processes in the system that make it self-sustaining again. And we won't be covering the work in our perennial systems with beaver dam analogs and PALs or post-assisted log structures, since many of you are familiar with that in Utah. But today we want to introduce you to another suite of techniques from Bill Zedike, who's been working on this topic for decades, wrote a book called Let the Water Do the Work. And we're going to share with you some of the ideas and concepts that he's perfected over the years to address channel incision in meadows. Ultimately, these techniques are about empowering you to be part of the solution. So we want you to open up your imagination and think about places where this type of work might complement the other types of restoration you'll be doing. Anytime we deal with hydrology, we're thinking at the watershed scale, right? Because it's all really connected. But today we're going to take us up into those upper, stream order 1, 0 order systems, those meadows, seeps, and springs is where we're going to focus our attention. And we'll talk really specifically about addressing this impairment of head cuts and channel incision. And what do we mean by a head cut? Head cuts that eroded, nick point or change in elevation in a meadow as you're walking up through it, where water, when it's flowing, will actually water fall over that lip and create a plunge pool that results in the leading edge of this kind of gully erosion process. Now below the head cut, we actually see the gully form, and that's the incised channel that really is disconnected from the floodplain and starts to concentrate the flow that runs off through these meadows. One of the key features to recognize in addressing meadow head cuts is understanding how they advance. And it's really a process of kind of once that vegetation is disturbed by either natural or human caused factors, soil gets washed away from the live roots, and those roots start to dry, and the vegetation actually dies out. So it's no longer able to hold those fine particle meadow soils together. And every year when you get that runoff event, more roots get washed, more vegetation dies, it falls into the trench, and it keeps migrating up valley until it hits some hard point. And this just keeps happening in a rinse and repeat fashion until we're able to stabilize the vegetation and get it to not erode anymore. Another key piece of the story here is the hydrology and understanding the difference between sheet flow and concentrated flow. Flowing water that is shallow and spread out moves slower, has time to infiltrate in the meadow, and has minimal erosive force. Whereas if we put all that same amount of water into a smaller area, it becomes concentrated, moves more rapidly, rushes off the landscape, and has a lot more stream power and erosive force. And so what we're wanting to maintain is that spread out flow, healthy vegetation that really results in robust meadow systems. Again, recapping those key processes that prevented this from happening, we're talking about the vegetation on the biology side and the sheet flow process on the hydrologic side. And here's a visual of a meadow and kind of the two different opportunities we have for restoration and preservation. This idea that at the head cut itself, there's a distinct change in our mindset. If we're able to address a head cut before it cuts up through a healthy meadow, that single action can be a preservation technique to save the meadow above from becoming degraded in the future. Whereas below the head cut, that incision's already happened, and we're talking about a multi-step process to kind of reconnect the valley bottom and bring that incised system back up. So Bill Zedike has a variety of techniques that have been taken from other historical work and then improved to come up with a suite of different sticks and stones approaches for preservation and restoration of meadow systems. And more importantly than what the names of these structures are that are that can take some of the be kind of mysterious and really make this seem more complex than it is, I want you to zoom out and think about what these structures are actually designed to do. And so we talk about three things. One is head cut control, second is grade control, and the third is restoring sheet flow. So Bill's got in his toolbox a whole suite of different types of individual structures designed to address head cuts specifically, from things like the Zuni bowl to log and fabric step falls where we have wood available, to rundowns, laybacks, and rock mulches that are all just variations of the similar concept, which is to stabilize the soils and vegetation at the head cut lip and allow water to gently step down from the higher elevation part of the meadow to the lower elevation part of the meadow, drop out some sediment, and allow that vegetation to reestablish. The grade control side, there's a variety of other structures, but by far the most popular is the one rock dam, which is neither one rock nor a dam, but it's one rock high. So we're actually hand placing these rocks, kind of like masonry work, to try to get those rocks to all work in unison together. This isn't the same as just dumping a pile of rocks in the gully and hoping it works. We're actually picking rocks, fitting them together so that water moves over the top of the structure in a uniform fashion and drops out any sediment that is in the system, allowing that vegetation to, again, recover, help build back up these degraded and eroded systems. And so these one rock dams are often placed in like the crossover sections of a channel, right? So if you think about a meandering channel, like a typical stream that has bends and straightaways, the bends are usually where the pools are. The straightaways are more like a riffle or a run. And then it's in those riffle or run areas where the natural grade control areas are that we would place these one rock dams to build this system back up over time. And finally, last suite of techniques here relates to restoration of sheet flow. And so these really are designed to spread water out. So if you have concentrated flow coming down through an area, we can put these types of structures in to kick water out back across the meadow. And media lunas are common, filter dams and worm ditches are sometimes used. And then completely different concept is the idea of a drift fence. And a drift fence is simply a segment of fence placed perpendicular to the valley bottom that is designed to prevent livestock and wildlife from trailing up and down the valley bottom. So oftentimes we get concentrated flow in animal trails because they like to walk up and down these valley bottom systems. But installing these drift fences can help change behavior of animals and get them actually up into the uplands and trailing up there rather than in our valley bottom. So just kind of wrapping up here, I want to remind everyone that these low-tech tools are just one tool in the toolbox, right? Don't forget that we still are doing a lot of other types of things to benefit our meadow and riparian systems. And this is designed to help expand your toolbox and give you an additional piece of the puzzle that you can implement with more people. We have a ton of different technical resources, from field guides to technical note that we wrote on some of the implementation in Colorado's Gunnison Basin. And I encourage you to check out those resources. And then finally, as I mentioned at the beginning, we just did this virtual workshop for statewide partners in Utah. You can go to this website or QR code, and there you'll find a series of more in-depth modules that kind of step you through the planning, implementation, and monitoring of these types of techniques. And I'll leave some of our contacts here in the state that would really encourage you to check and check with those folks on where this work's happening. We're establishing a demonstration site around Emma Park that perhaps some of you will get to tour if you want to be able to see this on the ground. So with that, I thank you, and feel free to reach out to me as well if you have any additional questions.